Okay, so the next topic is HTML5 3D graphics. So we have learned a few graphics technology that comes with HTML5, Canvas, and SVG. Mainly we focused on 2D side. So here we are going to look into how we can draw 3D graphics. So the actual technologies that we are going to use are going to be WebGL, and then we are going to use two other technologies that are built. So 3.js is actually built on the top of WebGL, and so this is the focus of our presentation and hands-on lab exercises. So we are going to look into how we can build simple 3D applications using 3.js, and we are going to see how we can add some optional features such as lightning and material and fixture and things like that, and some extensions and some loading models. So models could be actually created by some using some third-party tool, and then you can actually load those models into your 3D application. And then tQuery.js, that is in fact built on the top of 3.js. Okay, so let's move on with WebGL. So this is the evolution of 3D graphics support in browser. So in 1994, VLML and VLML 97, XXX3D, and Collada 2007. And then from 2011, WebGL is was adopted as a standard for browser 3D rendering. So what is WebGL? So it's a new 3D API standard for the browser. So you don't need any more plugin to have a 3D to be rendered on your browser. It is based on what is called the OpenGL ES 2.0, and it stands for OpenGL for Embedded Systems. Okay, so OpenGL ES is designed to enable high performance 2D and 3D graphics for mobile devices. Okay, so it's optimized for mobile devices, and that's what is actually being used by WebGL. Okay, the issue of WebGL is that it provides low-level APIs. Okay, so in fact it draws the canvas element. So yesterday we learned in order to draw 2D graphics, you are going to pass the 2D as a context value, and as you are going to see later on, in order to do 3D graphics, you are going to pass WebGL. Okay, it's supported by modern browsers. So if you actually take a look at the support level for WebGL right now, it's modern browser. So these are basically including all the mobile devices. So mobile devices do not actually support the WebGL well. So support level altogether, including mobile browsers, is only 33.61%. Okay, but desktop browsers, starting with the IE11, it has a reasonably good WebGL support. Okay, and it is being supported on many devices. So this is what we just have seen. Okay, so WebGL as a drawing API. So WebGL is just too complex as an API. So drawing APIs are just too low level. So if you take a look at WebGL code, it is very complex. It is very complex to write, and it is very complex to read. Okay, it does not support file format. It doesn't support any markup language, and it doesn't have any DOM. So basically that's the same thing as a markup language. So applications must define their own formats, and so in general, you are going to use high-level JavaScript abstraction libraries to do these 3D drawing. Okay. That's basically what we are going to focus on. So the most popular high-level abstraction of WebGL JavaScript library is 3.js. Okay, so it is the most popular one. Okay. Later on, you can also actually use tools like a Blender, Maya, SketchUp. These tools are actually created. These tools are used to create what is called a model. Model is just basically a capture of 3D object. So if you want to actually have some kind of 3D file created, then that file could be actually loaded in your 3D application. So we're going to do this exercise later on. So WebGL programming, as I said before, is pretty complex, and these are the steps you have to do. So you have to create the canvas element, and then you have to obtain a drawing context, and then you initialize a viewpoint, and then you get one or more buffers, and then you get the matrices, and then you get shaders, and then initialize shaders, and then you can draw things. The actual number of steps are not that bad, but the actual code for doing each of these tasks is pretty complex. Okay, so I don't expect you guys to actually focus on to learn WebGL programming, because that's not really something that we are going to use most of the time. Instead, we are going to use the 3.js. So it's just for your reference. Okay. So again, exercise 1 is we are going to actually do WebGL programming. We're going to just run the application. But again, the goal of this exercise is not to learn WebGL API, but to see how complicated and complex it is. Okay. So let's try. The first exercise is WebGL programming. So yeah, you want to actually start the HTTP server, okay, on this lab, and here we are going to try to run this guy. So this is the very simple WebGL. It's not even the 3D. It's just drawing the triangle. Okay, so not that much exciting. So if you take a look at the code, well, let's actually go to the next step first, and then so this is actually adding some colors, and the next you are going to do so the colors, and this one is now we actually kind of moving these things sort of the 3D fashion. Okay. And then we are going to do, now we can actually have some real 3D objects being displayed. Okay. Now let's take a look at the first code. So this is the code. This is the code that does this. Okay. So you can see at the end, it's basically it does a few steps like the init GL, init shaders, init buffers, and set the colors, enable, and things like that. So a number of steps in this code is not that bad. But take a look at this code, like a drawing scene and init buffers and shaders and all those stuff. Now the getting the context object. So here you can see is actually calling get context method of the canvas object, passing WebGL. Okay, so yesterday when we do canvas, 2D canvas, you're actually passing 2D, right? Here you're passing WebGL. Okay, all right, so that's that. So let me just move on. So WebGL API itself is very complex, so we don't want to actually spend time on it. So we're going to actually move on to a popular library called the 3.js. So 3.js is built on the top of WebGL, so it provides high-level APIs. Okay, so what is and why 3.js? So it's a JavaScript library that abstracts the complexity of WebGL, and it is open source. So you can actually find various 3.js sample applications. So the best place to go is, in fact, go to 3.js.org file. That's the home site, and you can see that in fact the many sample applications you can run. Okay, so let me just run some of this. Yeah, so this is probably not that much. Yeah, so this is something. Yeah, this is actually showing you with the video, so that's not that much exciting. Let's see, what is the thing? Yeah, let me try this. Oh, this is the sample application things. What about this? Okay, so it's the automobile. Yeah, looks like it doesn't allow me to move things around. Okay, so you can certainly take a look at the some of these examples. And this location contains a lot of sample applications. So if you want to learn a bit more detailed programming of 3.js, you're gonna actually spend quite a bit of time learning those APIs. But you can certainly take a look at these examples as well. And learning 3.js, many tutorials as well on this website. Okay, so alright, so those are the resources you can take advantage of. Okay, so the things that make up 3.js application. First, you need to have what is called a scene. So scene is constructed using camera and objects to be drawn. Okay, and object could be a mesh with geometry and texture. And then you also need renderer object, and renderer object draws a scene using one of the following. It could be render using WebGL, Canvas, or SVG. We're going to mostly focus on WebGL version of it. And you can also add other things, for example, lighting, animation, mouse control, and things like that. Okay, so if you don't understand what I'm talking about on this slide, don't worry about it. We're going to actually do step by step the drawing of 3.js application. Basically, just remember you need a renderer object, and then you need a scene that contains objects to be drawn. Okay, and then you can add extra features like this. Okay, so we are going to build simplest possible 3.js application. So these are the steps. The first step is you can create a renderer. Okay, and then the second step is create a scene, and the third step is create a camera, and step 4 is create objects. Okay, create objects and add them to the scene, and then you're going to render the scene. Okay, from camera side point. Okay, so we're going to actually take a look at each of these steps in a bit more detail. So if you don't understand what I just talked about on this slide, again, don't worry about it. Alright, so step number 1. You're going to create a renderer. So renderer is the one that renders a scene from camera's eye point. Okay, so the way that you are going to render a scene later on, once you create the scene and camera, is you're going to call renderer.render, and you provide a scene that contains the objects that you want to draw, and then you also provide a camera object that actually provides the eye point. Okay, now let's see how you can create a renderer. So this is the way that you are going to create WebGL renderer. So you can create the canvas renderer, or you can create a SVG renderer, but we are mostly focused on WebGL renderer. Okay, so you say 3.WebGL renderer method, then what you get back is WebGL renderer object. Okay, and then you are going to set the size of that renderer. So you can actually set the size in any length of your choice. Here I'm actually setting to the window width and height. Okay, so that it will actually use complete space of that window, meaning browser window. Okay, but you can actually set in any length of your choice. And then what you want to do is that you're going to get the DOM element representation of the renderer. So renderer has to be actually DOM element. So you are going to actually have a DOM element of the renderer, and then you are adding that DOM element into a body of your document. Here you can actually add this DOM element to any DOM element. So in this case, we are adding to body. Okay, so that again we are actually taking the complete body space. Okay, but you might have another div element that you want to actually render. In that case, probably you have that reference of that div element, and then you can append the child of your renderer DOM representation. Okay. Okay, so as I said before, that there are three different types of renderers. So WebGL renderer displays scenes using WebGL, and of course if your device supports it, and it provides a better performance than Canvas renderer. So Canvas renderer displays a scene using Canvas 2D context. Okay, so it's not actually, it's actually kind of displaying using like a 2D. Okay, if your device does not support WebGL, then this could be a fallback. Okay, and another type of renderer you can use is SVG renderer. Okay, so you create the renderer, in this case WebGL renderer object. Now you're going to create a scene object. So scene object is the one that contains objects to be displayed. Okay, so if you want to display like a sphere or the cube, you have to add those things to the scene. So that's something we're going to actually do in the following step. Okay, so here we created a scene. So you basically call the scene method of 3 object. Okay, then you're going to create the camera. Okay, so camera represents viewer's eye point. Okay, so the way that, by the way, you can actually create the 2 different type of camera objects. So let me actually show you 2 different type of camera object. One is orthographic camera, and the other one is a perspective camera. So perspective camera, as you can see on your right, kind of give you a sort of the 3D dimensional perspective. Okay, so typically you're going to use a perspective camera. Okay, so let's actually get back to the code. So here we are creating perspective camera object, and you pass 4 different values. Field of view, sometimes called the FOV, and then you specify the aspect ratio, and then you specify near and far values. Okay, and I'm going to explain these things in a few minutes using a slide, using a picture. Okay, so for now, just remember that when you are creating perspective camera object, you are passing these 4 arguments, and then you specify where you want to place your camera, and then you also specify what direction the camera is supposed to look at. Okay, all right. So we just learned about the difference between these 2 different type of cameras. All right, so this is the 4 arguments that you are passing when you're creating perspective camera. Okay, so the FOV is the field of view is the angle of how much you want to capture. Okay, so depending on depending on how much you are going to capture, so this one, maybe this is a 30 degrees or 40 degrees. If you say 60 degrees, it will be bigger. Okay, all right, so that's FOV. Aspect is width by height. Okay, so this is the aspect of your TV, basically 9 to 5 or whatever, right? Okay, and then we have a near point and far point. So near point and far point is that the objects only between these 2, near and far, will be captured, meaning they are going to be rendered. If you have an object before near or after far, those are not going to be rendered. Okay, so only objects that are placed in between near and far will be rendered. Okay, all right. Okay, so what we have done so far is that we created the renderer object, and we created scene object, and we created the camera object. Yeah, so these 3 objects you could actually create in different order. Okay, all right. Now we are going to create objects and then add them to the scene that we created. So here we are going to create a cube object. So you can call 3.js provides some primitive geometry objects such as a cube and sphere. So here we are trying to create a cube that is 2 units wide and tall and deep. Okay, so we created a cube object represented by this geometry the variable, and then you are going to create what is called the material. Okay, we're going to actually talk about the material in the following slide. And then using that object and material, you're going to create what is called a mesh. Okay, again, we're going to talk about what mesh is in a few minutes. Okay, and then you're going to add that mesh. So mesh is representing object that you want to display. Okay, so you just call the add method on your scene object to add that mesh object. Alright, so what is an object? So object represent a thing to be drawn. Okay, it could be sphere, it could be a cube, it could be some model object and things like that. Okay, so as I said, 3.js provides a built-in object types. The mesh, line, sprite, ribbon, particle, and things like that. Okay. Okay, so what is a mesh? You can think of mesh as a collection of points and a set of surface parameters. Okay. So, you know, this is sort of the technical description of mesh, but you can think of a mesh as just a thing. So geometry could be plane, cube, sphere, torus, and 3D text, and more. So what is a material? Material describes appearance of object. Okay, so if you have like a sphere object or cube object or person object, you know, you might in fact actually have some appearance on it. You know, you might want to have a glossy appearance, or you might want to actually have some kind of tattoo on it, right? So those things could be represented as a material. Okay, so these materials are defined in a mostly render independent way, so that you can actually, you know, you don't have to rewrite materials if you decide to use a different renderer. So, you know, you might in fact create the one bird tattoo material, and that material could be used for many objects that you want to actually draw. Okay, the 3.js in fact have multiple material types predefined: basic material, normal material, and Lambert material, and Phong material. Okay, and we are going to see some of these examples later on. And its material can be created with a color, so you might in fact have a different color, or texture. Texture is maybe some kind of tattoo, you know, the representing a bird or something like that. All right. So once you create an object with, you know, with the material, you know, and added that to the scene, you can have multiple objects on a scene, of course. Okay, and then you can render a scene. So basically, in order to render, you have to pass scene object and camera object, and then you call render method of renderer object. Okay, so pretty straightforward, right? Okay. All right, so let's do exercise 2, which is basically going through these steps of creating a very simple the object. Okay, so, you know, we are going to actually draw cubes. So here, if you click this one, you can see this cube is drawn. Okay, and let's take a look at the code. So here we created a renderer. So these are the steps that we just talked about. We create a renderer, create a scene, create a camera, and then create an object and add it to the scene, and then we render. Okay. So if you take a look at this code, you know, basically it is what we just talked about using the slide. Okay. So I'm not going to actually go over this one more time. Okay. And so this is pretty much exactly the same code that we have seen. Okay. All right, so that is for drawing a cube. Okay, here we are going to draw the sphere. Okay, we draw a sphere, and is exactly the same code, except that the object that we are drawing is sphere geometry rather than cube geometry. Okay, and this one is drawing a torus. Okay, like this, and again the object. We just have to change the object. Okay, so we are just using torus geometry object. Okay, now 2.4, we are going to play around with what is called the 3.js editor. So this is the browser-based tool that you can actually play around with the 3D graphics rendering a bit. Okay, so you know, basically we are going to just add a few things. Cube, yeah. So let's actually try to run this guy. And yeah, so I have already have a sphere. You can actually, you know, delete it. You can just click and delete. Okay, so you can add cube. Okay, and you can change the size. Yeah, you can change the size. Maybe this is a scale. Okay, so 5 or something like that. Okay, and you can add a cylinder, and you can move around like this. Okay, so it gives you properties of those cylinders and things like that. Okay. Okay, guys, I'm going to give you guys about 15 minutes, and we'll have a 15 minutes break. And that 15 minutes is basically to give you a chance to go over that code step by step. Okay, and get some understanding in terms of how to create a very simple 3.js program. Okay, so we'll be back in 30 minutes. And of course, I'm around, so feel free to ask any questions. And of course, as I said yesterday, do some experimentation. Just don't follow the lab document blindly. Do your own experimentation. Okay. All right. So the next topic is optional features. How we can add optional features such as lighting. Okay. Okay, so the first optional feature we want to add is animation. Okay, so that is in fact the request animation frame, the library API that you can use for animation. So basically what you do is, you are going to create a handler called whatever name of your choice. I'm going to name it as animate here. Okay, and inside animate function, you are going to call request animate frame and then provide the name of your function. So it's going to be called recursively in a sense. And then you provide the object, mesh object, in this case, rotation position. So you're basically adding, the 1 pixel, the 001 pixels. And then we are going to call render. Okay. So, and then we are calling animate, and once we call the animate, and this is going to be just called recursively. Okay, and every time it gets called, it will change the position of the mesh object. So that's basically what it does. So that's adding for adding animation. Now the second optional feature we want to do is adding a texture to a surface of an object. So as I said before, a texture is some graphics that you want to add to a surface of an object. Okay, so in this case, we are going to add a Duke image. So we're actually doing a tattoo Duke image to this cube object. Okay, so here we are going to create a texture object. Okay, so we are going to call image utilities load texture and provide the image file that we are going to use as a tattooed material. And then when we're creating a material object, we are going to add a color as well as this texture. Okay, on the this line number task number 3. Okay, all right. So that is the way that we can add texture. Okay, and we're going to do all this exercise in a few minutes. And you can also add light to the scene. So here you can actually add multiple different types of light: point light, hemisphere light. In fact, there are 5 different lights: directional light, and depending on the light scheme that you chose, it will actually obviously have a different light scheme. And then basically you are going to add that light. Okay. So here we have a point light that has some kind of color, the argument. And then we set the point light, so point position set. This is where the point is going to start. The light is going to get started, and you are adding that light to the scene. Okay? So, yeah, in terms of lighting, there are 5 different types of lighting: ambient, point, directional, and spotlight, and hemisphere light. So we're going to actually exercise all these different types of light to get the sense of, how they look different. And you can also actually have a shading, so flat, Lambertian, and Gauraud, a Fong. All right, so let's do exercise 3. So here we are going to animate this cube. So if you run this guy, you can now see this is being animated. Okay. Now, if you take a look at the code, basically we are we are basically creating a function called, in this case, render, And inside the render method, we are going to call request animation frame and providing name of the function, and then we are just adding the new position for the mesh object, and then we call render, and this is again being called repetitively. So that's the reason, you know, the it's actually being turning around. Okay, so try to change this value and see whether that's gonna actually, you know, how that's gonna actually affect it. Okay, it might actually kind of, you know, the run faster. Okay. Okay, so that's for animation. The next thing is add texture. So in this case, what we want to do is we want to add a Duke image as a tattoo on the surface of this object. Okay. So here, basically we are going to create a texture object, and we have used the Duke JPG file, and then we just added that texture to when we create the material. Okay, and you can certainly change the color to something else. So you basically can change the color as well as texture. Okay. Okay, so that is for adding a color and texture, and the next one is lighting. So what we are going to do is, you know, we are going to actually use this 3.js editor. Okay, so let's actually run this guy and remove this guy first, because we want to use the sphere. Okay, so I'm going to remove, select it, and then press delete key, and then say yes. And we're going to actually remove this guy as well. Cylinder, select, and delete. And let's remove this hemisphere light. Yeah, this is something that I play around. That's the reason it is there. So I'm going to just delete. So we're actually starting from clean state. Okay, so I'm going to add sphere. Okay, so we have added sphere whose position is 0, 0, 0. Okay, right? And so nothing really, you know, I mean, you can certainly see, you can certainly add materials in here, and, you know, things like that. Okay, so mostly we are going to focus on lighting. Okay, so the first lighting we want to try is, for example, point light. Okay, so this is the point light, and you can actually move around. Okay, and see how that point light in this case is actually pointing from the back of the sphere. So that's the reason. And here is actually, and you can see the position of this point light is changing. So, you know, take a look at the position value over here. Okay, so you can certainly use this value when you're actually adding a point light to this to the scene. Okay, and you can also have an intensity. So intensity is 1. So let's see what happens if the intensity is, let's say, 5. Let's see how intense. Yeah, it is very intense. Okay, so we don't want that intensity. So let's just change it back to. Okay, yeah, I like 1 better. So we'll just use 1. Okay. Okay, and distance. Let's see. What is this distance thing? It's actually 4. Is it 0? What happens is this like 2. I'm not sure what this distance is all about. Okay, so we'll just keep it as, you know, the 0. Okay, so this is the point light. Okay, so let's actually remove this point light and then try different light, and we'll try spotlight this time. Yeah, spotlight is like a spotlight. You know, so if you buy a spotlight from your hardware store, this is what actually gets spot. It's basically having a spot. Okay, again, you can actually move things around. Okay, like this. Again, it's actually from the back. Okay, and the distance wise, it will have a different impact, right? Okay, and again, intensity and color. Yeah, you can change the color as well. So let's see if you can change the color. Yeah, so the color is now changed. Okay, so that is a spotlight. So here we have spotlight and spotlight target. Okay, so target is representing this guy. Okay, okay, so we are going to remove spotlight, and and spotlight target as well. And now let's try to add another directional light. Okay, so directional light is yeah, so it just kind of give you a, yeah, so depending on, you know, I mean, depending on the distance and all that stuff, you know, it might actually have the same impact regardless. You know, the directional light and the spotlight, they might actually give the same, let's say, visual, you know, the effect. Okay, so this is basically, it just have the directional light right here. Okay, so that is directional light. Okay, now let's remove directional light, and again we remove the target. Yeah, you can certainly actually, you know, for example, you can actually have a directional light, and you can certainly change the target as well. So you can change the target position to maybe 1, something like that, and see what happens. Yeah, so targets, this is a position. Yeah, actually changing target. Did we change this one to 0? Yeah, so instead of actually pointing, instead of actually kind of directing over here, is basically, you know, pointing different direction. That's pretty much what the target can be actually set. All right, so we'll delete both of this, and let's try hemisphere light. So hemisphere light is basically, it gives you a, you know, hemisphere kind of feeling. Okay, so you know, the actual color is blue, and the ground color is, in this case, this. You can certainly change it. Okay, so depending on where it is, you know, it will actually give you a different the coloring scheme. Okay, so that's hemisphere light, and we'll remove that one. And the last one is ambient light. Yeah, so ambient light is basically, the color is, in this case, black, so it doesn't make any difference, but you can just change the color to something else like this. Oh, I didn't change. Select this one and say OK. Oh, why it doesn't change? Oh, okay, so it changed. Okay, so this is ambient light. Okay, so it like changed the whole thing. Okay, all right, so that is the lighting scheme. So let's see. Yeah, so we just did the exercise 3, and then the last one is, if you run this code, if you run this one, you know, basically again playing around the ambient and directional and point and spot. If you just remove all this, okay, we can just start with the ambient, and then directional, and then point and spot. And of course, it, you know, depending on the configuration of these the lighting object, right? So you can take a look at the code. So, you know, basically this is the code that has been added. Okay, so we just added this is how you add the ambient light, and this is how you add the directional light, and point light and spotlight. Okay, so initially this is all set. Okay, I mean, and also we have this GUI aspect where you can just click it and it will remove the ambient. So you can see, you know, this is a code that actually removes ambient light and remove the directional light and remove point light, depending on whether those options are in fact clicked in. Okay, all right, guys, I'm going to give you guys about the 7 minutes to try this. Next, we are going to see how we can add some extensions to 3.js. Okay, so the things that we are going to add include camera control and floor and sky and things like that. So let's see how we can add camera control. Camera control lets you move your camera viewpoint using your mouse. Okay. So what I'm saying is we can actually just try this one. Camera so here we can just go to camera control. So here you are going to have, and then you can actually move things around. You can move your mouse, and depending on your mouse, it will actually kind of zoom in and zoom out, right? Okay. So basically, I'm actually using camera control. Okay. Okay. So that is camera control. Wait a minute. Yeah. So yeah. Yes. I can behave. Okay. It's still animating, but I can actually change its behavior using my mouse control. So that is camera control. So you're going to use 3x library, drag pan control.js file, and then you're going to create the camera control object from this drag pan control. And then basically, you're going to update the scene every time you are moving your mouse. Is basically, is going to, set the control. Okay, so that is camera control. You can also add the floor and sky. Okay, so let's actually try that. So here, what we can do is, yeah, so this is what you are going to see. So if I do this, you can see now I have a floor and the sky as well. And again, my mouse is still working. So we are basically adding new features one by one. Okay, so that is a floor and sky. Okay, so yeah, I'm gonna actually explain the code later on. And here, add window resize. So in this case, let me again demonstrate the windows resize. Yeah, so let me just talk about the code as well. Yeah, so I might as well just add, to talk about this code. Did I actually talk about this code? Yeah, I talked about that from the slide. And this is adding, this is basically adding a floor, and this is for adding a sky. Okay, so here we get the floor texture, and then we actually set the some wrapping and repeat to the texture, and then we can actually make a double side, render texture on both sides of the mesh. Okay, and it works pretty much the same for sky as well. Okay, so that's adding a floor and sky, and this is window resize. Now in this case, when we're actually running this guy, and let's actually try to run this guy one more time. Now, even if I so I should actually start with this. Okay, let me actually start from this. Okay, so now it's actually taking up the whole space. Now, if I extend this one, you can see the graphics itself is not extending. So I have these white spaces, and obviously this is not really desirable. What I want to do is that whenever I'm extending the window size, I want this graphics to also increase the to match, to expand. Okay, all right, so that is basically what I want to do. So that is yeah, so here I showed you. So I'm going to just show the code using the hands-on lab. Okay, so we are going to use the again window resize.js file, and basically transparently support the window size. All you have to do is just setting the renderer with the camera with window resize and bind. So we are binding the renderer with the window size. Okay, so that's all you have to do. Okay, the next one is yeah, so add statistics. You want to actually find out how things are performing on your graphics. So basically providing a simple info box that helps you monitor your code performance. So the performance information I like to capture include two things: FPS, frames rendered in the last second. The higher the number, the better. and ms is milliseconds needed to render a frame. So the lower the number, the better. Okay, so in order to do that, you're going to use a stat.js library, and then we are going to create a stats object, and then basically within your animation loop, we are just updating the statistics. Okay, so let's try that one. Statistics, and here, so whenever I'm doing things, you can see, the information is being captured on the left lower corner, right? And it does even have some graphics. Why it doesn't actually display MS, I'm not sure. Okay. That is adding for statistics. Screenshot. So sometimes you want to have a screenshot. So in order to do that, you can actually use a screenshot.js file. So here basically when you create a renderer object, WebGL renderer object, you say anti-alias to get the smoother output, and then preserve drawing buffer true to allow the screenshot. And then here you are going to actually bind the key P to the screenshot. So when you press the P, it will capture the screen. Okay, so let's try that. So we did the statistics, and this is a screenshot. So here I'm going to do this, and if I press the P, then screenshot is made. So you can see the PNG file has been created. Okay, so that's a screenshot. And the last one is a full screen. So if you want to actually display things in full screen, in this case we check whether full screen is available, and then we are going to bind key F with the full screen. Okay, so let's see whether that should work. Full screen. So this is a full screen. So full screen, I'm gonna press F. Okay, so now I'm gonna press F. Okay, now you can see everything is full screen. Okay, so exit full screen, coming back, and that's the end of this particular the section of the presentation. So this is for extensions. Okay, so I'm gonna give you guys about the 7 minutes up to 10 minutes after hour to try this extension. Next topic is loading 3D models. So there are few tools out there for creating 3.js compatible JSON files. So these JSON files are representing some models. Okay, so examples include Blender, Maya, CTM, FBS, and 3D Max, and Collada. So these tools are used to create the model representing some, the gaming character and things like that. And then you can actually load that model, just like, the geographic object that we have loaded up to this point. Okay, so let's try exercise 5. So in this case, if you run it, you are going to see this object, this spaceship object I borrowed from, I forgot where it was, is actually being loaded on the screen, on this rendering screen. Okay, so this file is actually a model that we have imported, loaded into this application. Okay, so if you take a look at the code, okay, so this file is actually in the form of PNG file, and then we have created material, and then we just get the loader object, and we basically loaded it. Okay, so it's a JavaScript object. So yeah, so this JavaScript object is representing, not JavaScript object, the JSON object. If you take a look at the uf4.js file, so let's take a look at the uf4.js models. Okay, this one is, yeah, so this is a JSON object representing that spaceship. Okay, and you can actually create this JSON object using those tools that I actually mentioned. Okay, and basically we just load that the JSON object representing the model, and then we also have light, and then so basically key aspect of this code is this. Okay. And we're just rotating that the spaceship as well. Okay. All right. So I'm gonna actually finish up the presentation, and then I'll give you guys some time to play around it. Okay. Okay. The next, so this is a Blender. Blender is the open source 3D generation tool. Okay, and you can use other tools as well. So you can certainly see some of the things you can create, right? Okay. All right, let's move on to tQuery.js. So if you see 3.js is reasonably complicated, okay? It's actually much better than WebGL API, but it's still, relatively complicated. So what community is doing right now is to create another layer on the top of 3.js, and tQuery is actually one effort of it. So it's very simple to build the tQuery, the application. It was actually built with a plugin architecture, so that whatever. So let me actually explain the architecture in the following slide. So it's a thin library on the top of 3.js. It provides an extension system for people to write plugins. So it's in fact actually using plugin systems like a jQuery. So so instead of actually you write the code from the scratch every single time that you're writing graphics application, the idea of tQuery is simplicity plus you want the take advantage of the plugins created by different people. Okay, so these plugins could represent some kind of gaming screen or whatever, so anything can be created in the form of a plugin. Then you can just take advantage of it. So basically having this architecture, reusability of the code can be dramatically increased. Okay, so to help them share their code and build on the top of each other, and mimics jQuery API and well known for its usability. So it's basically trying to simulate the plugin system of the jQuery. So I mean, it's possible there are a lot of, let's say, game related the plugins that you can use right away in your tQuery application. Okay. tQuery API aims for it should not be harder than playing with a Lego block. So again, with a plugin system, you can just kind of assemble the blocks, in this case plugins, to write your graphics application. All right, so let's see exercise 6. So we're gonna just do very simple the tQuery exercise. It's basically we are going to run tQuery sample application that does just this. Okay, and it does have all the features that we have worked on. Okay, pretty much all the features. Okay, and if you see the code, this is it. So basically all you have to do is just adding tQuery JavaScript library, and then you create a word boilerplate, and then start, and then you add an object to the word. Okay, and here you can modify the code instead of what did I modify here? Oh, so yeah, I should actually highlight this one. Instead of doing a torus, you can display cube. Okay, I should actually add an exercise leveraging plugins out there. So in fact, if you go to tQuery, so let's see what kind of plugins people have. I'm gonna just go for tQuery. tQuery. So let me just search it. Yeah, so tQuery, a tQuery website. Yeah, so display the car. Yeah, so these are the plugins. Okay, so which means that you should be able to actually use any of these plugins in your application. Okay. Ah, nice. Okay, cool. So I'm going to give you guys 10 minutes to do exercise 5 and 6. Okay.